Okay, in this video we'll be talking about doing rotations of rigid motions, and we're going to start with a 90-degree counterclockwise. So the first thing you need to realize about your quadrant is that the coordinate plane is divided into four quadrants, and the first two quadrants are like quadrants 1 and quadrant 2. In quadrant number 1, both the x and y axes are positive, so that means every point within quadrant 1 has to be positive for the x and positive for the y. In quadrant number 2, the x is negative and the y is positive, so every point in quadrant number 2 has to have a negative x and a positive y. Now let's go ahead and look at quadrant number 3. You can see the x is negative and the y is also negative. So that means quadrant number 3, every point in quadrant number 3 is negative on the x and a negative on the y. And then finally in quadrant number 4, the last one, we can see that the x's are positive and the y's are negative. So any point within there will be a positive x and a negative y. So really, what does that mean? Well, first of all, when we do a rotation, rule number 1 is that all points take the signs of its quadrant. So if a point lies in a certain quadrant, make sure you label it correctly with the right signs. Now the second rule when you're doing a rotation is that for every 90 degrees of rotation, the x and y values switch places. So here we go. Let me zoom in here a little bit. Suppose we have a point A, and let's say A is the point 4 and 3. So 4 and 3. We're in quadrant number, the first quadrant, so that means both x and y's are positive. Now for every 90 degrees of rotation, so if I go from the first one to the second quadrant, I go a 90-degree rotation, the x and y values switch ordered pairs. So that means our new point A will be the 3 and 4 switch places, and then the ordered pair takes the sign of the quadrant, which will make the 3 a negative and the 4 will be positive. So all points take the sign of its quadrant. So we'll go ahead and change that. So the 3 is negative. So when we graph that ordered pair, 3 and up 4, that's where the new A would be if I rotate it 90 degrees from the first quadrant. Okay, let's say that we're going to take it from quadrant 2 and we're going to move it to quadrant 3. So remember, every 90 degrees what happens is it switches. So now that negative 3 and 4, the 3 and 4 will switch places. That means our new point is going to move 90 degrees. 4 will become the x, 3 will become the y. So point A will be 4 and 3. And you see it when we're in quadrant number 3. So both of those will be negative. Now we'll go ahead and graph that, a negative 3, negative 4, and down 3, so that's our new point A. And remember, they always switch. So as I go from quadrant number 3 to quadrant number 4, they're going to switch again. So I go another 90 degrees, they switch. So let's see, I would have an ordered pair of 3 and 4. And in this quadrant, the x is positive and the y is negative. So that would be a negative 4. So I'd go over to the right 3 and then down 4. And that is the process of doing a rotation. And I know we're not using a three-dimensional figure. We'll do that in a second, but that's the basic idea there. In the next part of this video, we're going to be actually doing a problem. We're going to take this triangle and we're going to rotate it counterclockwise 90 degrees. And we're going to use the rules that we just talked about. So remember that all points take the signs of its quadrant. We talked about that a little bit. So make sure you use this diagram over here to get the signs correct on your ordered pair. You can see that all our points are in quadrant number 3. And we also need to remember that for every 90 degrees, the X and Y switches. And also remember the way that we rotate. And it looks like we're going to be rotating counterclockwise, 90 degrees. So that means we're going to be moving one quadrant. And we're going counterclockwise. So we're going to go from, it looks like quadrant 3 to quadrant number 4. So the next best thing to do right here is to list the signs of your quadrant that you're ending up in and that you're starting in, so you make sure you label your points correctly. Now we're just going to go ahead and list our ordered pair. So we have the triangle CDE, start with C. C, let's find the origin. The center is right there. We go to the left 3, so that's a -3. And we go down 4. So you start there, 1, 2, 3, 4, down 4, -4. Now we go ahead and list the ordered pair for D for our pre-image. Looks like we go to the left 4 and down 2. -4, down 2, so that'd be a -2. And now we have E. E looks like just a -1 and 1, so they're identical numbers, and both of them are negative. Now we're ready to switch our ordered pair. Remember, they switch for every 90 degrees that we rotate. Don't forget that. So the X becomes the Y, and the Y becomes the X. So that 4 is going to become the X, will become the X, and the 3 will become the Y. And then we take the signs of the quadrant, which will make that 3 negative, because that's the Y part of the ordered pair. So that'll be a -3. Now let's go ahead and do it for D. D is in 2 and 4 because they switch places, and then a 4 will be negative, right? Because the Y is negative in the 4th quadrant. Now let's look at E. E will be 1 and 1, and then the only one that will be negative this time will be the Y part of that ordered pair. Now let's go ahead and plot them. We know we're going to be in quadrant number 4, so we have C prime. See, there is 4 to the right, 3 down, so there's C prime. D is 2 to the right, 4 down. I guess C was 4 to the right, 3 down. I had that wrong. And then now E is 1 to the right and then 1 down. Now we'll go ahead and connect our points. And you'll see we'll have a congruent image. Now a congruent image is one that has the same shape and size. It just has a different orientation on the page. So now we know that those two have gone through a rigid transformation of 90 degrees counterclockwise. So that is our image, and the other one is our pre-image.